Allan Green. I'm from CSIRO Plant Industry in Canberra in Australia, and I'm the Deputy Chief of the division there. The talk that I gave was really covering what the potential was to replace petrochemicals by chemicals derived from plant oils. And the issue there is, can we produce enough plant oils on top of what we need for food production in the future years to be able to provide a good supply. And if you do the calculations, we currently produce about 140 million tonnes of plant oils, mostly for food. We'd need to produce nearly 100 million tonnes additional by 2050 for an additional 2 billion in population. If we want to replace the say 40% of the petrochemicals currently coming from petroleum with chemicals coming from plant oils, we would need to produce another 140 million. So if you add that up, that gets you into the 400 million tonnes from our current level of 140 million tonnes. The greenhouse gas situation we have now with increased levels of carbon dioxide has really come from 100 years of reliance on petroleum and taking carbon out of the ground and up into the atmosphere. We have to change that. So if we really want to stop global warming and start to remediate, sequester some of the carbon out of the atmosphere, we should actually stop mining and using petroleum as earlier rather than later, not wait till its supply runs out, but start to shift to renewable technologies. It's a transitional thing, obviously, and this is a big issue for, I think, governments and agribusinesses. How do you develop the new industries while you're still heavily economically reliant on the current industries? But it is an issue that we do have to bite the bullet on and find ways of transitioning rather than get into a situation where we don't have time to transition in a planned way. There's a lot of activity from various companies now focused on particular target molecules that they believe there's a strong market for, and putting in place the production systems or the conversion systems from agricultural feedstocks to chemical platforms for industry. But I think we've got a long way to run in terms of being able to make a wide spectrum of molecules that we get from the petrochemical sector through plant or bio-based feedstocks. I think that's all doable, but you just have to do all that research and development to get to that position. I think it's still early days because most of the focus has been on biofuels, because that's one of the easiest things to do with vegetable oil is to convert it to biodiesel and effectively to burn it as a replacement for the fuel sector of the petroleum economy, if you like. But that's one of the least desirable things to do. It's the lowest value return for a grower to grow a product for burning just for its energy value. And it also means that some of that carbon is actually going back into the atmosphere. A better approach is to develop high-value materials, replacing the petrochemical rather than the energy sector of the economy. That should return better value to farmers and should lock away more of that carbon into building products and the like. Most of the changes we'd want to make to produce specific compounds in plants will require the introduction of biosynthetic pathways, and the only way we can do that is through genetic engineering. So there's a tremendous potential that unlocks to produce a range of compounds in plants. Also, if we want to move from low oil content to high oil content in some of our major crops, like soybeans, for instance, or cottonseed, both of them are only 20% oil. But if we could move them up to 45–50% oil, that could provide another 100 million tonnes of oil globally. That's a big shift, and that will only happen through metabolic engineering. Because it is a fairly urgent thing we need to do. It takes 10 years to develop a variety for farmers, and in 10 years we'll have another billion people. So we've got to go faster than the problem is advancing at. And so I think we need to put in critical mass now.